Hello, I'm River, and I'm here to narrate Manifolds Explained. The hidden category in math. In mathematics, the category of manifolds, often denoted man P, is the category whose objects are manifolds of smoothness class C P, and whose morphisms are P times continuously differentiable maps. This forms a category because the composition of two C P maps is again continuous and of class C P. One is often interested only in C P manifolds modeled on spaces in a fixed category A, and the category of such manifolds is denoted man P, A. Similarly, the category of C P manifolds modeled on a fixed space East is denoted man P, E. One may also speak of the category of smooth manifolds, man infinity, or the category of analytic manifolds, man omega. Mathematics often hides elegant structures beneath complex surfaces, and now we'll explore Manifolds Explained. The hidden category in math. Like many categories, the category man P is a concrete category, meaning its objects are sets with additional structure, i.e. a topology and an equivalence class of atlases of charts defining a C-P differentiable structure, and its morphisms are functions preserving this structure. There is a natural forgetful functor, U man P right arrow top, to the category of topological spaces, which assigns to each manifold the underlying topological space, and to each P times continuously differentiable function the underlying continuous function of topological spaces. Similarly, there is a natural forgetful functor, U man P right arrow set, to the category of sets which assigns to each manifold the underlying set, and to each P times continuously differentiable function the underlying function. Finally, for all 0 P Q infinity there are natural inclusion functors. Man omega right arrow man infinity right arrow man Q right arrow man P right arrow man 0. In other words, one can always see the category of smoother manifolds as a subcategory of less smooth manifolds all the way down to man 0, the category of topological manifolds with continuous maps between them. Obviously, these inclusions are not full. Continuous maps may not be Q-differentiable, Q-differentiable maps may not be P-differentiable, P-differentiable maps may not be smooth, and smooth maps may not be analytic, nor replete. Similarly as said with maps, homeomorphisms are not in general diffeomorphisms, and so on, nor wide. Not all topological manifolds are differentiable, and so on, so they can be viewed as strict subcategories. It is often convenient or necessary to work with the category of manifolds along with a distinguished point, man P, analogous to top, the category of pointed spaces. The objects of man P are pairs M P0, where M is a C P manifold along with a basepoint P0 M, and its morphisms are basepoint preserving P times continuously differentiable maps, e.g. F M P0 right arrow N Q0 such that F P0 equals Q. The category of pointed manifolds is an example of a comma category man. P is exactly $scriptstal bold down arrow math man P. Where bold represents an arbitrary singleton set, and the down arrow represents a map from that singleton to an element of man P picking out a basepoint. The tangent space construction can be viewed as a functor from man P to vect R as follows. Given pointed manifolds M P0 and N F P0 with a C P map F M P0 right arrow N F P0, between them we can assign the vector spaces T P0 man T F P0, N with a linear map between them given by the push-forward differential F P. TP0 M right arrow TFP0 N. This construction is a genuine functor because the push-forward of the identity map 1 M. M right arrow M is the vector space isomorphism 1 M P0. TP0 M right arrow TP0 M, and the chain rule ensures that FG-P0 equals FG-P0, G-P0. Mathematics reveals a surprising and elegant structure through the concept of manifolds.